Hi, I'm Tom George, and this is my Physics 2212 Lab 1 charge tapes. So, what is charge? Well, charge is an intrinsic property of matter that's based off of the relative number of electrons and protons that an object has, and it's measured in coulombs. It cannot be created or destroyed. Now, two objects that both have charges can exert a force upon each other, as expressed by Coulomb's law, which is shown to the right. This force is attractive if the two objects have different charges, and repulsive if the two objects have similar charge. So the purpose of this lab is to understand the properties of charge and to determine how much excess/deficient charge is stored on each piece of tape. How are we going to do this? Well, we're going to use Glowscript and a real-world experiment to create a situation in which we can solve for the charge on each tape and some related values. We will do this using Coulomb's law and Newton's second law. And the result was that the charge on each tape is equal to 6.53 times 10 to the negative 9 coulombs. So the initial conditions of the experiment were that the tape does not have any other charge, and that outside of gravity, there are no forces acting upon it. So when the two U tapes were made, they initially repelled each other. This meant that they had the same charge. The U tape was slightly attracted to the neutral objects that I held it up against, such as a textbook and a pencil. And by rubbing the pencil through my hair, giving it a negative charge, the pencil, we observed, was strongly attracted to the tape. Because of this, we can conclude that the charge of each U-tape was positive. This means that when we ripped it off the base tape to create the U-tape, it lost electrons. So, experimental conclusions. So our assumptions were that, in the diagram to the left, that tape B is the system and tape A is the surroundings, and there are no other forces, that the tape acts as a point charge, and that the charge on both pieces is the same. Now, the reason we have these assumptions is so that we can draw conclusions. While in that position, depicted on the left, tape B is not accelerating. This means, by Newton's second law, the net force acting on tape B must be zero. Now, tape B has two main forces acting on it: the electric force from tape A acting in the positive y direction, and the gravitational force acting in the negative y direction. Combining these two facts leads us to the conclusion that these forces are equal to each other in magnitude, as depicted in this free body diagram. Now, so these are the calculations. We set the gravitational force equal to the electric force, and we use the variables that we measured during the experiment, namely the distance between the two tapes and the mass of the tape, in order to calculate the estimated charge on each tape, which was 6.53 times 10 to the negative 9 coulombs. And since each electron has the same charge, we can figure out the number of deficient electrons on each piece of tape, which we found to be 4.1 times 10 to the 10th power electrons. We could also figure out the ratio of atoms to electrons on each piece of tape, which we found to be about 7 million atoms for every electron. So for coding, I basically made a code that was very similar to the calculations we did a couple slides prior, where you plug in the mass of the tape and the distance between the two tapes to determine how much charge is necessary for the tape to float on top of the other tape, which, considering the calculations were the exact same, leads us to get the exact same result. And you can see on the diagram to the right that the gravitational force and the electrostatic force are the same. So what are some possible sources of error? Realistically, charges are not distributed at a single point, but they're distributed over the entire tape. Now, this would lead us to an inaccurate number for the amount of charge on each tape. Other theoretical forces like wind were not accounted for, and so could have affected the calculations. In the process of handling the tape, some of the charge may have left the tape, leading to an underestimation of the amount of charge that the tape could hold originally. And because each tape was created independent of each other, it's likely that they didn't have the exact same charge, which would affect the calculation. Why is it important to handle the charged tapes as little as possible? Well, when the charged tape comes into contact with your hand, oftentimes some of the charge can diffuse off. And so basically it would lead to an inaccurate calculation because each tape would lose charge. And what if electrons had positive charge and protons had negative charge? Well, this wouldn't actually really make much of a difference. Essentially, The reason that charges with less electrons are considered positive is purely a matter of conventions. In the end, those with a similar charge will repel and those with opposite charges will attract, regardless of whether they're positive or negative. In conclusion, items with charges can have a force on each other. This force is always equal and opposite. Neutral objects can be attracted to charged objects, and objects can gain charge through friction and other methods. Thank you.